All right, let's talk about big data. For years, we had this incredible power to process huge data sets, but it came at a price. It was agonizingly slow. Today, we're going to dig into the breakthrough that changed everything. So, if you've ever worked with a big database, you know that feeling, right? Staring at the screen, just waiting for a query to finish. Now, imagine that, but your data is so massive it doesn't even fit on one computer. That's the core challenge of big data. And for the longest time, the tools we had were powerful for sure, but man, were they slow. Okay, let's just put them side by side. For years, the undisputed king of big data was this thing called Hadoop MapReduce. I mean, it was revolutionary, but it had this one huge weakness. And then along comes Apache Spark and just completely changes the game. It didn't just tweak the old way, it totally rethought the process, and in doing so, unlocked this massive leap in performance. So, to really get why Spark was such a game changer, we have to look back first. We need to understand the problem it was built to solve. What was it exactly that was holding Hadoop MapReduce back? Yeah, what was the big challenge? Honestly, you can boil it down to one word: disk. Hadoop was built around this constant cycle of reading data from a disk, doing a little bit of work, and then writing the results right back to that disk. And it did this over and over and over again. I mean, just look at this process. The thing that should jump out at you is just how many steps there are. For every single tiny part of a job, Hadoop had to go through this whole dance. Read, compute, write. Read, compute, write. All of that back and forth to a physical spinning disk created this enormous bottleneck. You know, the analogy I love is trying to cook a big meal, but after you touch any single ingredient, you have to walk back to the pantry and put it away before you can grab the next one. It works, it's methodical, but it is so inefficient. So the people who created Spark, they looked at this massive bottleneck and they asked a really simple but brilliant question. What if we could just skip the disk part, at least for all those intermediate steps? So how did Spark pull this off? What was the secret sauce that made it up to 100 times faster than the industry standard? I mean, that's not a small improvement. That's a whole new paradigm. The answer is a concept called in-memory processing. And honestly, the best way to think about it is right there on your own computer. It's the difference between grabbing a file from your super fast RAM versus waiting for a slow, spinning mechanical hard drive to find it. RAM is just orders of magnitude faster, and Spark was built from the ground up to take advantage of that speed. And this right here, this is the core difference. Instead of that slow, repetitive disk-based cycle, Spark just keeps all the intermediate data, all those in-between calculations and results, right in the computer's lightning-fast memory. By just cutting out that disk I/O, the putting the ingredients back in the pantry step, it completely unlocked a new level of speed. And this is what made it truly interactive big data analysis possible for the very first time. So this new way of thinking led to that incredible 100-to-1 speed up we've been talking about. But here's a surprising side effect of that speed: simplicity. Because the whole process was so much more direct, the code itself got way, way simpler. We're talking about cases where a task that took maybe 100 lines of really complex Java code in MapReduce could now be done in a single line of code in Spark. It was a huge win for developers. Okay, but all this speed, all this data just flying around in memory, it raises a really obvious and super important question, right? What about safety? And that is a totally fair question. We don't know that RAM is volatile. You pull the plug and poof, everything in it is just gone. So if one of your servers in the cluster crashes, what happens to the data it was holding in memory? How did Spark solve this huge risk and make in-memory processing safe enough for mission-critical jobs? Well, the answer is Spark's real secret weapon. It's this brilliant piece of engineering called the Resilient Distributed Dataset, or RDD for short. This is the absolute fundamental building block of every single Spark application. The real magic here is a property called lineage. See, Spark doesn't just store the final piece of data in memory. It remembers the exact recipe it used to create that data, every single step it took to get there. So if a machine goes down and a chunk of data is lost, Spark doesn't even panic. It just pulls out the recipe, finds another machine, and recreates that missing piece from scratch. This is the trick that makes in-memory processing both blazing fast and incredibly fault-tolerant.
All right, so now that we understand the engine, let's kind of zoom out and see how Spark fits into the bigger picture, because it's an incredibly powerful tool, but it doesn't work in a vacuum.
Right, so Spark is fantastic at computation, at the actual number crunching, but it's not a storage system itself. To work in a big environment, it needs two key partners, something to actually store the data long term, and something to manage the whole cluster of machines it's running on.
And this is where Spark's flexibility really shines. It's not some locked-down, closed system. It can read data from pretty much anywhere. The classic Hadoop file system, HDFS, or cloud storage like Amazon S3, you name it. And it can work with different cluster managers too. This plug-and-play design made it super easy for companies to start using Spark without having to tear down and rebuild their entire data infrastructure.
So if there's one thing you take away from all this, it's this. Spark completely changed the big data world by moving the heavy lifting from slow disk to fast memory. And it made that whole process safe and reliable using the clever design of RDDs. It really is that simple and that powerful. You know, Spark gave us this incredible 100x speedup by figuring out and conquering the disk bottleneck. But technology never, ever stands still. So it leaves us with this really interesting question. What's the next bottleneck? Where will the next 100x speedup in data processing come from? Hey, if you enjoyed this explainer and breaking all this down with us, please give it a share and subscribe for more. Thanks so much for tuning in.